Morning. So today I'm going to pick up where we left off with substitution, and we're going to tweak our strategy a little bit. So remember, when we're using substitution, we're really solving for a point of intersection, meaning eventually we want an x and y value. So if this is my system of equations and I want to solve, notice how x is already equal to something, and so I should be able to substitute with that into the other equation. So in other words, instead of 5 times x, it's going to be 5 times something minus 6y equals negative 49. And from there, I can say, well, x is exactly the same thing as negative 3y plus 7. So I can throw it in, and then I can simplify and solve. So if you haven't done that lesson already, definitely go back, watch the recording, do the assignment, and make sure you understand how substitution works. Because today we're going to expand on this idea. So one more time, remember the key to substitution is that one of the equations is equal to a variable. So what happens if that isn't the case? Same question, solve for the point of intersection. But notice how this equation is not a variable equals something, and neither is this one. So as it stands, we can't actually substitute here. But it turns out we have a strategy that will allow us to transform this into something we can substitute with. And what that's going to come down to is rearranging equations. So we will come back to this problem in just a little bit, but first I need to clarify what I mean by rearranging. So if we take a look, when I say rearranging, I want us, in this example, to adjust the equation so that it's x equals rather than what it is currently. So I've got two sides of my equation. Remember, 2x really means 2 times x. So if I wanted this equation to be just x equals, all I'm going to have to do is divide by 2 and divide by 2. So I'm just dividing by 2 so that I'm going to be left with x equals, but because I did that to the left side of the equation, I need to do that to the right side. So 10y divided by 2 is going to be 5y, and negative 8 divided by 2 is going to be negative 4. And there I have it. This is a rearranged equation that's now x equals. And if I want to do a little bit better here, and I want to verify that this is actually true, I'm going to type in the original. So our original equation was 10y minus 8, and sure enough, we get a line. And now if I throw in our new equation after rearranging, notice how I end up getting the same line. So I'm just proving that even though I tweaked how the equation looked, it's actually really the same thing. All right, let's clear that out of here. And so the reason this is going to be useful is now notice how this is an equation I would be able to substitute with because it's now x equals rather than 2x equals. So here's another case. And now this time, rather than turning it into x equals, I want to turn it into y equals. But this one's not quite as straightforward. It's going to require a little extra. So the first thing I need to do is notice how x and y are on the same side of the equation. First off, I got to fix that. So since I have minus 12x, I'm just going to add 12x to both sides. And now I'll have negative 3y left here. Notice how this is 15 and this is 12x, not like terms. I can't combine them because one has an x and one doesn't. So all I'm going to, wrong variable. I know my letters, I promise. All right. Now I'm just going to write it all on the same side. Now my goal is to make it y equals, not negative 3y equals. And so once again, remember that this really means negative 3 times y. So I'm just going to divide everything by negative 3. So it's going to leave me with y equals 15 divided by negative 3 is going to be negative 5. And 12 divided by negative 3 is going to be negative 4. And now once again, I've rearranged. Cool. The final case is, here I told you what I want you to have by itself. Last case is, I want you to decide. So there are going to be cases where one variable is going to be a heck of a lot easier than the other one for making it y equals or x equals. So if I'm looking at this case, I really got to decide, is it going to be better to make it x equals or y equals? My general go-to strategy is which number is smaller than the other one, and which number goes into the other one. What I mean by that is, notice how between the 16 and the 8, both attached to a variable, the 8 is smaller. Notice how 8 also goes into 16 2 times. And so, because 8 is smaller and goes into the other coefficient, I'm going to keep the y all by itself, and I'm going to decide, in this case, to subtract 16x from both sides. Hopefully you'll see why in just a second. So now I have 8y equals negative 24 minus 16x. And now, because it's 8 times y, I'll just divide both sides by 8. And so this will become negative 3, and this will become negative 2x. So notice how, because this is the smaller number and it goes into 16, we result in a whole number. If I had done the other way, I would have ended up with a fraction, which would be really ugly. And just to demonstrate, let me show you what I mean. This is just a side note, so you can skip it if you need to. But if I had instead done minus 8y to both sides, notice how I'd have to divide both sides by 16. There's nothing wrong with this, but 24 can't be nicely divided by 16, and so that would result in the fraction negative 24 over 16, and 8 can't be divided by 16 nicely, and so that would be this fraction. So this is a heck of a lot uglier than the opposite version. I could clean this up a little bit by reducing the fractions. Still not going to be great, but this would become negative 3 over 2. This would become minus a half. But still, if I compare this to this, I'm going to go with this every time. All right, cool. So this brings us back to the original situation that inspired learning rearranging. So now I want you to actually rearrange one of these equations for substitution. So if I'm asking you to solve for a point of intersection, but neither one is equal to a variable, I got to decide, can I rearrange one of them to make it work? Notice how x is already by itself in this first equation. So I'm going to go with this. I'm going to say, let's rearrange this guy. Well, this one's quick, where if I just add 3 to both sides, I now have x equals 5y plus 3. So I'm going to totally ignore this guy now, because I just rearranged it, and this format is a heck of a lot better for the purposes of substitution. So now I know that x is equal to 5y plus 3. So going back to my other equation here, I now know I can replace x with something, and that something is 5y plus 3. And then once again, I can solve this by substitution. So I'm not going to solve all the way. I'm just showing you how rearranging sets us up for substitution. But from here, you could solve this down to get a value for y, and then go back to this in order to solve for x. All right, sweet. Now, let's look at another case. This one is a lot less straightforward. I'm arguing that both of these equations actually are set up to either get a y equals situation or an x equals situation. So I can decide between the two. And maybe looking at this, I can see, oh, 7 and 14, I can definitely see the relationship here. So maybe I'll use the second equation in this case. So I've got 7x minus 14y equals 49. So first thing, 7 is smaller and 7 goes into 14. So that's why I'm deciding to move the y in this case. And now I can divide both sides by 7. And I'm going to end up with x equals 49 divided by 7 is 7. 14 divided by 7 is 2. And so now I know that x is equal to something. This is the one I rearranged, so I'm going to ignore it because I have it in a much better format now. And so I can take that and I can throw it into x value up here. All right, and then I can put in 7 plus 2y. And I'm good to substitute and solve. And that's all there is to it. So one more time, the whole idea is if neither of our equations are x equal or y equal, then we can't substitute until we rearrange one or the other. With that said, take a look at today's assignment. The first few problems are going to really guide you through, and then the last 2 problems are going to make you decide which one to use. Let me know if you have questions. Otherwise, good luck.